Hello everyone. I hope you all are good and you all are solving lots of questions. Let us for now solve this one, and this is going to be really an affair of very small time, I would say, because this just revolves around one small concept. So let's start with the question. Two small motors are there and they are kept on a smooth table at a separation L. So this table is a smooth, mu is equal to 0. Done hai? So no dissipative force there. The motors have mass m and 2m and are connected by a light thread. Okay, the motors begin to wrap the thread. अब देखो ये thread wrap कब होगा? ये thread का length क्या है? L length है, right? So for it to get wrapped, अब आप सोचो ये जब इधर की तरफ चलेगा तो ये ऐसे ऐसे रैप होता रहेगा ना. आई मीन सपोज कर लो मोटर इज हियर, दिस मोटर एंड दिस मोटर इज हियर. सो ओनली लेंथ ऑफ रोप रिमेन्ड इज दिस मच, right? So rest length of rope has been wrapped around these two motors. So that is about wrapping of this rope around the motor. ठीक है. Now what is said, the tension in the thread is maintained constant at F. So tension is constant. Okay. Find the time after which the two motors will collide. So the question is कि after what time they will collide, they will come at the same point, right? Neglect the dimension of the motors and their stands. Motor के dimension यानी कि इसको neglect करना है. Simply we have to understand that this is the initial position of motor, and when they will collide, they will be somewhere, and they at that point, let's say two motors are again indicated by dot because we have to neglect their dimension. Done it? So we will treat these two motors as a point particles. अब आप ध्यान से सोचो यहाँ पे सिस्टम में हो क्या रहा है. Why these two motors are able to move, under what force? So there is one force acting because of thread, that is tension force, and you know that tension always acts away from the body. So if you talk about this motor, there is force in this direction, that is tension. There is force in this direction, that is mass of motor into G, and then there is this normal reaction in the up sense. Since there is no motion in vertical sense, N will be equal to mg for both the motors. Such sort of equation we can write, and things will be in equilibrium, right? And for horizontal case, if you see, there is only one horizontal force acting, that is tension, right? Because there is no friction, right? So इस surface पे कोई friction है नहीं, friction will not operate. So only horizontal force acting on the motor is tension. Done है? And similarly for this one, if you see, the only force acting on the motor is tension. So if you are going to treat these two motors as a system, if I'm treating these two motors as a system, then is there any force acting from the outside of the system? So you will say no, because टेंशन क्या है, इन दोनों के बीच का फोर्स हो गया, राइट? टेंशन इज ऑपरेटिंग बिटवीन द थ्रेड दैट इज कनेक्टिंग बोथ मोटर 1 and 2. सो टेंशन ऑफ सिस्टम के बीच का फोर्स हो गया. डन है. So there is no net external force acting, and that is why if no net external force is acting, its center of mass position will remain fixed. It is not going to burst from, I mean, it is not going to move from its original position. So initially when two motors were not moving, at that point of time, what is the position of center of mass? So let's associate coordinate system like this. Suppose कर लो ये तुम्हारी x axis है and this is your y axis. Let's say this point is the origin. So taking this point as the origin, we can calculate center of mass of the system. Center of mass of the system क्या होगा तुम्हारा, m into 0 plus 2m into L divided by 2m plus m, that is 3m. So center of mass is at a point of 2L by 3. Done it? And if center of mass is somewhere here, center of mass will stay at that point. What does it? Why? Because there is no external force, net external force acting on the system. So center of mass यहीं पे रहने वाला है. इसका क्या मतलब हुआ? इसका simple मतलब ये हुआ कि if these two motors are coming together and colliding, so that coming together and colliding position must be the position of center of mass. क्योंकि center of mass shift नहीं होना है. So finally when these two motors will be at the same point, that same point should be the center of mass position point, right? डन है. क्योंकि अगर आपने मोटर को कहीं और कोलाइड कर दिया तो हमें ऐसा लगेगा कि सेंटर ऑफ मास यहाँ पे आ गया, विच इज नॉट पॉसिबल, राइट? सेंटर ऑफ मास का पोजीशन फिक्स रखना है. यानी कि फॉर कोलिजन दिस m मास मोटर शुड मूव बाय डिस्टेंस ऑफ हाउ मच, 2L by 3, and this will move by a distance of how much? L by 3. So we have to calculate in how much time it will go there. So time निकालना है ना, आप एक काम करो, this motion is happening under a constant force equal to tension that is given in question equal to F. So S equal to ut plus half at square equation we can use, because this is a case of constant acceleration, because force acting on this motor is constant. Done it? So let's calculate for this motor. I am going to calculate क्योंकि time taken by both will be same. एक ने L/3 चला तो उसने दूसरे ने 2L/3 चला. Done है? क्योंकि दोनों का mass different है, force is same but acceleration will be different. So for first motor अगर मैं निकालूं, किसी एक से आप निकाल लो, मैं first को use कर रही हूँ. Distance covered 2L/3. Initially they are at rest. They started moving under the influence of tension force, right? So initially they are at rest. Half acceleration F by m into t ka square. So if you solve it, t ka square will be equal to how much? 4ml by 3f. So time will be how much? Root under 4ml by 3f. This is going to be our answer. So this is a very simple question, just on the concept that if there is no external force acting on the system, center of mass position will not change. Done it? So initially if center of mass velocity was 0, finally also it will be 0. Initially if center of mass acceleration is 0, finally also it is 0, because there is no external force acting on this. Okay, I hope you have understood this question. And even if you are having still some doubt somewhere, you can always let me know in the comment section. Thank you.